Hey everyone, welcome back to the channel. Right now, something is moving through our solar system that has top scientists completely baffled. An interstellar visitor named 3I Atlas just shattered every expectation we had about objects from beyond our cosmic neighborhood, and the data coming back is genuinely disturbing. We're not talking about minor inconsistencies here. We're talking about measurements that contradict fundamental physics, emissions that defy explanation, and a scientist with the courage to say what others won't. Avi Loeb, one of the most respected voices in astrophysics, is looking at the numbers and asking questions that make the entire scientific community uncomfortable. This isn't another routine discovery. The images captured show behavior that shouldn't exist if 3I Atlas is just a natural comet drifting through space. The observations challenge certainties we've relied on for decades, and what's emerging is a case that forces us to confront possibilities we've been trained to dismiss. Loeb isn't making wild claims. He's doing something far more powerful. He's demanding that we treat the data seriously, follow where it leads, and stop pretending we have answers when we clearly don't. The verdict, as he puts it bluntly, should not be decided by authority. It should be decided by data. And right now, that data is telling a story that doesn't fit comfortably into any natural explanation we currently have. The measurements are real. The anomalies are documented. And the window to gather more evidence is closing fast. So what exactly did we see that triggered this level of scientific alarm? What numbers aren't adding up? And why is one of the world's leading astrophysicists willing to risk his reputation by suggesting we consider explanations that most scientists won't even whisper about? Stay with me, because what I'm about to show you will change how you think about what's possible. Here's where everything started going sideways. When astronomers captured the sharpest images available of 3I Atlas, they noticed something that immediately stood out as wrong. The emissions coming off this object, the plumes of material being ejected into space, weren't behaving the way comet emissions are supposed to behave. And this isn't a subtle difference. This is physics 101 level stuff that's being violated. Let me explain what should happen. When a comet gets close to the sun, solar radiation heats up the surface ice. That ice sublimates, meaning it turns directly from solid to gas without becoming liquid first. The gas escapes, and here's the critical part. It gets pushed radially outward, away from the sunday. This creates the classic comet tail that always points away from our star. It's predictable. It's consistent. It's been observed thousands of times. 3I Atlas is doing something completely different. The emissions around this object are aligned with its direction of motion, not radiating away from the sunday. Think about what that means. The plumes are following the path of travel, which is not how thermal sublimation works. Loeb saw this and immediately recognized it as a diagnostic signal demanding serious attention. Now, there are a few possible explanations, and none of them are comfortable. It could be a projection effect, an optical illusion caused by how we're viewing the object. It could be real mass emission guided by unusual geological features on the surface. Or, and this is where things get interesting, it could be directional thrust from a localized source. Each of these options has wildly different implications for what 3I Atlas actually is. Loeb makes it crystal clear that only velocity measurements and composition analysis can separate these hypotheses. We need Doppler shift measurements of the plume spectral lines. We need to quantify the mass flux and compare it against sublimation models. Without these specific numbers, any narrative that tries to close this case early is premature and unscientific. The scientific priority is obvious. Get the measurements, test the hypotheses, stop guessing, and start measuring. What do you think is really going on with 3I Atlas? Drop your theories in the comments below, and let's figure this out together. And if you're hooked on this mystery, hit that subscribe button, because we're following this story all the way to the answer. The emission pattern was just the beginning. When Loeb's team started running the actual calculations on how much material 3I Atlas is ejecting, they hit a wall that shouldn't exist. The math reveals something deeply wrong with the natural explanation, and the numbers are so extreme that they force us into uncomfortable territory. Here's how the calculation works. You measure the brightness and extension of the plumes coming off the object. From that brightness, you estimate the density of particles required to produce that level of light reflection. Then you combine that density with a typical outflow speed for ejected material. Multiply density times speed times the cross-sectional area, and you get mass flux per unit time. The amount of material being thrown off this object per second, per minute, per hour. When scientists ran these numbers for 3I Atlas, they got values in the range of billions of tons per month, depending on which parameters you use. Now here's where it gets absolutely wild. Take that mass of ice, let's say it's carbon dioxide ice, since that's a common comet component, and calculate how much energy you need to sublimate that volume. Turn it from solid into gas. The energy requirements for sublimation are well established. We know exactly how much heat you need. And when you calculate how much solar energy is actually hitting an object the size of 3I Atlas at its distance from the sun, the numbers don't come close, not even remotely close. The sun cannot provide enough energy to the estimated surface area of this object to sublimate the amount of material that's being observed. Loeb's conclusion is direct and unavoidable. If we insist this is purely thermal sublimation, we have to admit that the active areas on 3I Atlas would need to be absurdly large, larger than the body itself. That's physically impossible. Or we have to propose that there's an additional energy source we haven't accounted for. Neither option fits standard comet models. This is why Loeb is pushing so hard for observational tests of alternative scenarios. The energy budget doesn't balance. The mass flux exceeds what solar heating can explain. And when basic physics stops working, you don't get to just ignore it and move on. You have to confront what the data is actually telling you, even if it points toward conclusions that sound impossible. So what's the alternative Loeb is proposing, and why is it causing such controversy? He's presenting, with full scientific responsibility, a hypothesis that most researchers won't touch. What if those directionally oriented jets aren't random emissions at all? What if they're controlled thrusters, with exhaust being launched intentionally toward the sun to generate thrust that alters the trajectory in a calculated way? Before anyone jumps to conclusions, understand what Loeb is actually saying here. This is not a declaration that 3I Atlas is an alien probe. It's a working hypothesis with clear, testable, observational consequences, and that's what separates real science from speculation. If those jets are artificial thrusters rather than natural sublimation, they would produce exhaust patterns with fundamentally different characteristics. The composition would be distinct from icy plumes. You'd expect to see metallic signatures or molecular compounds not typical of water or carbon dioxide sublimation. The escape velocities would be different. Artificial propulsion can generate much higher exhaust speeds than thermal processes. And here's the key. The emission spectra would show elements and molecules that don't belong in a comet. You'd see signatures that point toward machinery rather than ice. Beyond composition, there's the timing factor. Natural thermal activity fluctuates randomly based on solar heating, rotation, and surface properties. Controlled thrusters would show organized behavior. On-off cycles, directional changes that correlate with trajectory adjustments. Intensity variations that follow a pattern rather than chaos. The scientific value of this hypothesis is precisely that it can be tested. Loeb isn't asking anyone to believe anything. He's demanding that we transform the idea into measurable predictions and then go get the data to confirm or refute it. That's how science is supposed to work. You don't dismiss uncomfortable hypotheses because they sound strange. You test them. And testing requires specific observations that the community needs to prioritize immediately before 3I Atlas moves beyond range of our best instruments. Let's bring this all together and understand why this case matters so much. 3I Atlas was officially discovered on July 1st, 2025 by the Atlas system operating in Chile. The detection triggered an immediate international observation campaign because objects with hyperbolic trajectories, meaning they're not gravitationally bound to our sun, are incredibly rare and scientifically valuable. Pre-discovery images were later found in archives, which is standard practice, but the real monitoring began that summer. What makes 3I Atlas different from the previous interstellar visitors? We've had two others. One, Oumuamua, which showed asteroid-like signatures and strange acceleration, and 2I Borisov, which behaved more like a traditional comet. 3I Atlas combines the worst of both worlds for people trying to explain it naturally. It's potentially massive, with upper limit estimates from Hubble images reaching approximately 5.6 kilometers in diameter. That's huge compared to what we expected. It shows vigorous activity at distances where comets shouldn't be that active, and it has spectral features that don't fit clean categories. Then there's the trajectory itself. It's hyperbolic and retrograde, meaning it's moving opposite to the direction most solar system objects orbit. And it's traveling very close to the ecliptic plane, the flat disk where planets orbit. That's statistically unusual for a random interstellar object. On top of that, its path brought it close to Mars in early October 2025. It reached perihelion, the closest point to the Sun, in late October. And it's heading toward peak visibility from Earth in mid-December 2025, with a close gravitational interaction with Jupiter expected in 2026. The scientific community has mobilized hard. The Mars Reconnaissance Orbiter captured crucial images on October 2nd when 3I Atlas passed near the red planet. Space telescopes and ground-based observatories are coordinating to gather multi-band observations. The goal is to nail down velocity measurements through Doppler shifts, composition through spectroscopy, and temporal evolution by watching whether the jets respond to control or follow random thermal patterns. Loeb's demand is simple and non-negotiable. Get the data before declaring victory for any explanation. Right now, we have three possibilities on the table: observational misinterpretation, unknown comet physics, or additional energy sources that could be natural or artificial. Without velocity, composition, and timing data, we're just guessing. And the clock is ticking. So what's your take? Are we looking at misinterpreted data, bizarre natural physics we've never seen before, or something that forces us to expand what we think is possible? Drop your thoughts in the comments. Let's debate this. And make sure you're subscribed because this story is far from over, and you don't want to miss what happens next.